Great. Good afternoon, everybody. Well, good morning still. So my name is Haghighi. Thank you for being here to listen to my talk about distributed cloud. So I want to tell you how you can actually build your applications once and deploy it anywhere. And that's basically through OpenShift that you're going to find out shortly. So just a little bit about myself and the team. I head up Hybrid Cloud Build Team for IBM in Europe, Middle East, and Africa. Hybrid Cloud Build Team basically enables clients and partners to develop the skills they need to build solutions with IBM's open hybrid cloud technology. So we've got developers, architects, data scientists, and business development managers within Hybrid Cloud Build Team to engage partners through architectural whiteboard sessions, hands-on workshops, and also we help them to co-create their MVPs to accelerate their time to market. Before I dive into my talk, I want to tell you, I want to introduce you our team. So basically, I'm fortunate to be working with an amazing team of developer advocates and data scientists who are passionately engaging developers and communities in various client partners and open source communities. So as developer advocates working for IBM, the pioneer of many technologies and inventions with a history of over a century, we've got certain messages that we need to get to the world. And that means to the world as a whole, to talk to all developers and tell them what sort of technologies we've got to offer. And we do that using a special methodology called Code Content Community. And basically, Code Content Community is all about all the materials and ingredients that developers need to build a solution. So the code, as the name suggests, is the code, the repo, for developers to build their solutions. And we basically provide them in a package that they can easily get it up and running in less than 20 or 40 minutes. And then the content, or all the great videos and tutorials that we've got on developer.ibm.com, and the community, we as developer advocates, we are there running a lot of meetups and workshops to enable them, to show them how they can do things, to educate them. And if you're interested also, since this conference is happening in London, we've got our great meetup page on meetup.com, IBM Code London. So make sure you sign up for some of our events. We've got a lot of free educational sessions, teaching developers how they can actually build solutions as fast as possible. Part of our job description is just being out there at these conferences, at major events, digital channels, and contributing to many open source projects. At the same time, not only we do the outbound, but also the inbound. So we have to be out there talking to users like yourselves, and who's got their hands on technology, and we need to talk to you to get your pain points and understand exactly what we can improve in IBM offerings, and obviously to improve that experience with our products and services. So that combination of outbound and inbound activities defines who we are and keeps us enthusiastic to make even better and deeper impact. That's basically just a quick introduction about our team. But then that gets me to the next part, which is about hybrid cloud. So what are the motivations for having multi-cloud applications or hybrid cloud applications? So in our conversations with clients, partners, and depending on whom we are talking to, motivations for hybrid cloud is subjective. Cost reduction is always that common reason in a majority of our conversations with C-level execs. But that one aside, C-level executives are mostly interested in providing business flexibility to their clients and delight them with new and competitive features. Developers are looking for ways to expedite their journey from development to testing, staging, and production. Operation engineers, on the other hand, they're basically motivated to simplify the operation, increase the security, and obviously reduce the cost. But for the last decade or so, there has been this new team called DevOps, which sits somewhere between developers and operation engineers. And they're basically interested in one important factor, and that's basically portability. And as I will explain to you later, OpenShift meets all the requirements that DevOps teams are interested in. But again, bear with me. I'm going to go through that one by one and show you why OpenShift actually is the best platform for developers and operation engineers and DevOps. So now let's go back to the most important factor for DevOps engineers, portability. So we've got different types of portabilities: application portability, workload portability, and function portability. For applications, as the name suggests, it's about moving your applications without downtime, significant rewrite and disruption between one cloud and another, like from one cloud to another. Workload is about moving your workload according to the application requirement and portfolio. And functions or services are basically ways for you to package your solutions and being able to basically offer it on multiple clouds. If you look at different cloud providers, again, I tried to be very conservative, and I did include the figures that some of those basically could define what sort of services you can services and specifications you can get from different public cloud providers. But different cloud providers, public clouds, basically environments have different specifications, and sometimes your workload, your applications may require different sort of a specific requirement that you can't actually just put it on one cloud, and you need to kind of break down your applications and put it on multiple clouds. That's one reason. And then obviously, if you look at IBM Cloud, that was about Azure, AWS, and GCP. But if you look at IBM Cloud, we are a pioneer of hybrid cloud. We offer all types of cloud solutions, and our cloud has been designed to, with our industry expertise across all 20 sectors. But the most important aspect of our cloud is about the security. So when I speak with the developers on our partners and client side, the most important factor they mention about IBM Cloud is the fact that the security of our platform is number one from their perspective. And I'm just quoting some of our enterprise clients. And again, security is a very important aspect of today's business solutions. But all of that is all about matching the right workload to the right cloud environment for your business, whether it's about your applications, your workload, or your services. So that's why you need to have your solution hosted on multiple clouds. But again, when it's basically about, from the DevOps perspective, when you talk to DevOps engineers, it's a very complex issue. It's not that easy. And I just want you to actually pay attention to this book. The Phoenix Project and the Unicorn Project, they're like some of the best books I've ever read. It explains all the complexities in DevOps world. And if you, for instance, a quick quote from Jim Whitehurst, who used to be the CEO of Red Hat and the president of IBM, he basically refers to this book as a must-read for all business and IT executives, because literally, it explains everything in a very simple language, and you understand the complex world of DevOps. And just like one quick example from this book, when it comes to code merges, it basically defines code merges as 50 screenwriters simultaneously working on a Hollywood script when they haven't even decided who the main characters are or what the ending will be, and whether it's a gritty or detective story. So that's the sort of thing that you basically experience when it comes to DevOps. But when we talk about code merges, it's in fact CI/CD. So that is how CI/CD is usually implemented. Developers practicing continuous integration merge their changes back to the main branch as often as possible. Those changes by developers are validated by creating a build and then running automated tests against the build. So that's basically what happens. But then continuous delivery automatically deploys all code changes to a testing and production environment for the build stage. And then the last one is finally delivery means every change that passes all the stages of your production pipeline is released to your customers. So the first transition is manual, whereas the second phase is automatic. And again, most of the complexity for DevOps is actually because of this. Now, this is the part that we're going to start talking about hybrid and multi-cloud. I want to ask you a question. How can we design an application that can be updated continually without downtime? Different teams can own and evolve different services, and our applications can be migrated from one cloud platform to another seamlessly. The answer to that is cloud native. Cloud native refers to how an application is built and deployed rather than where the application resides. It basically defines that the application must be built, delivered, and operated in a way that it is not hardwired to any infrastructure. So that's the important part. And how does that happen? It basically happens through microservices. Microservices architecture is the building block and the most essential ingredient of cloud native. A cloud native application consists of discrete reusable components known as microservices that are designed to integrate into any cloud environment. And that's the beauty of that, because it is designed to be integrated into any cloud environment. You can easily move it from one platform to another. But then, if you want to look at it, from, how actually, if you want to define microservices, this is the best way I can describe it. Microservices architecture basically addresses all the liabilities that are inherent in monolithic applications. And I'm going to talk about monolithic applications shortly, because that's the traditional way of building and deploying an application. Microservices architecture, basically, what does it say then? It says you've got to partition large monolithic applications into smaller pieces, into smaller independent services that can communicate with each other using HTTP and messages. So once you do that, so for instance, we've got this sort of application server, which is for a store. So you've got your catalog, your recommendation service, your billing and inventory, all kind of bundled up as one application. And if any one of these basically services goes down, because you've basically designed it as one entity, as a single entity, your entire application could easily go down. Whereas when you actually look at it from the microservices perspective, based on their business functionalities, we partition the application into microservices, and if one of them actually goes down, if the billing service goes down, it doesn't mean that your catalog service is going to be down as well. So different services can continue operating if something happens to them, or if you are basically adding a new service, or you are kind of making changes or updates to your services. So that's the most important part about microservices. So once you partition your application, your services become highly maintainable and testable. They're loosely coupled, independently deployable, so you don't need to wait for other services to be completely up and running before you can actually update a service. And then they're organized around business functionality. So this way you can actually divide it and allocate it to different teams. So let's take a look at an example. This is a monolithic application. So we've got our analytics, data parser, user interface, and data visualizations, all bundled as one application. And this is something that I built during the pandemic for analyzing COVID-19 data. First, I designed it as a monolithic application. Every time I wanted to update one service, I had to update the entire service. And if I wanted to scale the application, I had to scale the entire application. And I wasn't able to actually scale individual services. So what happens is, with microservices, you break it down, and once you break it down, you can actually use different languages, different technologies, and this way you've got your microservices completely independent from each other. And then you containerize them, which I'm going to show you later. But here are the top advantages of microservices when you do that. Your services can evolve on different timelines. Your services can be deployed separately. You can choose your technology stack according to what best fits the purpose, so you don't have to stick to a single programming language or a single platform or a framework. And then you can scale your individual services dynamically at runtime. But the most important aspect is the fact that if a single microservice fails, the overall application remains functional. That's the most important one from the enterprise perspective. Now going back to this, so once you've got your microservices, you need to containerize them. When you containerize them, they basically become independently deployable. So you can easily just deploy each one of those containers on any cloud environment. And that's basically how you can move your application from one cloud platform to another. But there is another thing to that. Let's take a look at the key drivers. Obviously, the application performance will improve massively. You've got more flexibility and speed, given that you've kind of broken down your application into multiple pieces, and different teams can evolve them on different timelines. And obviously, because of that, the adoption has become quite widespread. Because if you look at, for instance, some of the figures coming from the analyst firms, a lot of applications are moving to cloud, and more than half of them are going to be cloud native this year and next year. So that's, again, why you need to focus on cloud native. There is another advantage to that is basically based on what I said, that different teams can evolve different services on their own timeline and use their own technologies. Definitely the culture is going to become, you can boost the culture in your developers team or DevOps and operations teams. So, for instance, as I said, they can own different services. They can continue and centrally integrate their source code updates across the team. And a pipeline that deploys apps in a development, test, staging, production environment. You can easily have different teams working on your application without any conflicts between them. So that's one of the other advantages of cloud native for teamwork. But I mentioned about monolithic applications. In the old days, when everything was monolithic applications, they were designed and operated as a single entity. I'm just giving you this, sort of description just for you to understand how that worked in the past. So monolithic applications, they didn't have any sort of agility. So agile didn't really work for monolithic applications. If they wanted to make updates, each team had to wait for the other teams to finish their updates before they can actually make those updates happen. Every time they wanted to work on adding new features, they had to check everything with all the teams to make sure that everything's going to be exactly compatible with the other components. But again, the same thing happens in cloud native, but it is in an agile environment, because everything is basically designed as APIs and there are messages between the microservices. So that's much faster. I'm not saying there's no communication, but the sort of process, the communication between the team is much faster. And obviously, if something goes wrong, people are not going to be pointing fingers saying like that was your fault or my fault. People have their own sort of functions and responsibilities, and they're fully aware of what they're doing. Because in the past, it used to be like if the system goes down, they used to say, oh, it's your fault, it's your fault. But this way, you can easily find out which service is not working properly. And again, when that happens, it's like Titanic, basically. The whole system was kind of designed in a way that it was modular. So when there is a hole, the ship is going to sink. So now the question is, let's say we've partitioned our application into a lot of microservices, and we've got a lot of microservices. It's a big application, but how are we going to orchestrate our microservices? Scale them based on demand for each one of those individual services and make updates to those microservices. Again, that still remains a big problem, because if you want to do each, scale and update each one of those microservices, that's a long process. And that's basically Kubernetes. So Kubernetes is in charge of doing that. It's an open source system for automating deployment, scaling, management of containerized applications. So what does Kubernetes offer? A multi-container application must run on a multi-host environment in order to eliminate that single point of failure. So if one host went down, our orchestration tool can easily switch the load to another host. So that's one. The second one is we need to be able to create new instances of our individual microservices containers to scale accordingly. So that's the second one that I was talking about. So again, you don't want to do that manually. So you leave that to Kubernetes, and Kubernetes will take care of that. And it's an open source platform. You don't need to, it's available free of charge. Obviously, you can use the managed service, but it's available free of charge. And again, when one or more of our services need to be updated, or let's say our team is adding a new feature to the application, the orchestration platform must be able to automatically schedule new deployments and create new instances of our containers with zero downtime, or nearly zero downtime, basically. So that's what Kubernetes basically takes care of. Every time you make a new update, Kubernetes takes the new update and then apply it accordingly without causing the application to go down. And obviously, Kubernetes scales and manages our containers according to the available underlying resources on the host. And that's a very important one, because you don't want to scale it without having the actual resources available. And last but not least is Kubernetes checks our containers continually to make sure they're healthy. And in case of any failure, it will take actions to reinstate our deployment and create new instances and restore the services. So that's basically what Kubernetes does for you. And it's all automatic. And I'm going to show you the commands. It basically takes about 12 commands to deploy an application, to containerize a microservice and deploy it on Kubernetes. So to sum up, with Kubernetes, we state what we desire about our application, such as the number of instances of our individual microservices, the allocated resources. And then Kubernetes, observes the actual state of our application and will keep on adjusting and readjusting our resources to make that happen. So it is always that continuous reconciliation of our observed and desired state. So let's go back to our previous diagram. So let's take a look at at the deployment scenario on a high level. How are we going to deploy our applications onto Kubernetes? So in the last stage, I showed you that we containerize our microservices. So we broke down our applications into microservices and containerized them with Docker. Let's say we are using Docker in this case. So deploying each Docker container with Kubernetes will spin up a new pod with this Docker container in there. Based on our deployment scenario and the load, each pod basically gets replicated, and that way we are making new instances of our Docker containers. So that's basically how we can create replicas. So we first created a deployment, then scale our application, our deployment accordingly. The next step is to create services. So when we do that, we allow our applications, our microservices, to communicate with each other within the cluster, and also expose our applications to internet and the external network. So that's a simple process. And this is basically what happens within Kubernetes cluster. How do we do that? First of all, to containerize our application, we use Docker. If you're using a Docker file, we create our Docker file, and then we say build, Docker images, Docker run, and that's it. We've got our containers. And then, so this is a very simple process. All developers know how to do it. So you get your containers. And then this is what you need to put in your Docker file. Just where it's coming from, where's your image, the arguments. That's it, simple. And then the next step, when you get to the Kubernetes side, is use kube-control, kubectl. People call it differently. So use that to create a deployment, expose a deployment, scale it, and roll out new updates. That's basically, those are the commands you use that. But obviously, if you've got updates for a batch operation, if you've got a lot of microservices, you can actually use YAML to do that, to apply those kind of operations to a lot of microservices. And if you want to look at it, what happens exactly, you as a developer, we can revisit our deployment scenario, this time in more detail, to see what's happening under the hood. First, we use kube-control CLI tool to interact with the Kubernetes cluster. Then the kube-control lets you control Kubernetes cluster and its resources. Think of kube-control as a magic word. So every time you put kubectl, kube-control, you're basically instructing your CLI to work with Kubernetes from your terminal. And then going back to our deployment scenario, we instruct the master node to create deployment based on the given container. The master node processes our request through its API server and runs a scheduler service that automates when and where the containers are deployed based on our declaration. And then each worker node includes a Docker and a software agent called kubelet that receives and executes orders from master node. These are just like some detailed operation, what's happening in the Kubernetes. And then kubelet spins up a new pod for every instances of our container, and then to expose our application to the external network or internet, our master node creates a service to direct traffic to our pods through worker nodes, kube proxy components. That was just like unnecessary details, but I wanted you to know what's actually happening inside Kubernetes. But then, as you have seen, learning Kubernetes, it took about 12 actually commands to containerize and then deploy your applications onto Kubernetes. But having to containerize your microservices and working from a command line interface, they're not ideal for developers. Developers, data scientists, they just want to get up and get their code in and just push, commit, and push. That's it from their Git. And exactly this is what I'm going to explain to you. You don't want to learn Kubernetes. And that's basically through OpenShift. So Red Hat OpenShift is exactly what developers and data scientists need these days, and I will explain to you how. So OpenShift is built on top of Kubernetes and brings along all the brilliant features of Kubernetes, but it bundles Kubernetes with some essential features that will ultimately provide the best experience to both operation engineers and developers. And that's basically through a number of automated workflows, which are not available in Kubernetes. So those automated workflows are the results of these components that you see in this diagram. So Kubernetes is wrapped around an enterprise-grade Linux operating system, networking, monitoring, registry, authorization, and authentication services. So that's why you get a lot of productivity features. Let's go through that. The first one is, as a developer, you want to get started on coding as quickly as possible, rather than spending time learning about different platforms, tools, and services. So OpenShift comes with pre-created quick start applications. So whether you're a Java developer, Python developer, Go developer, you can easily use one of those pre-created templates to get your application up and running with literally one click. And then the second one is you want to focus on coding and not worrying about what's going to happen in the background whenever you make changes available in your code, in your repo, on your Git. So with Kubernetes, with OpenShift, basically, you can get your CI/CD pipeline up and running, and just push and commit and push. And I will explain to you how this happens basically. Because as I explained to you with Kubernetes, you have to containerize your application and then deploy it. So every time you make changes, you have to containerize it and then deploy it. But then OpenShift basically takes care of that. The other one, the third feature, is the fact that you've got code-ready containers, which is the local version of OpenShift on your own machine. So you can actually test it out on your laptop before you put it on a public cloud or on your private cloud. But then you may wonder how this actually works. So this is an overview of what we just explored with respect to that one-click notion. So OpenShift basically takes care of building and deploying your application. Developers can focus on coding, and the rest of the process is taken care of by OpenShift. So that's basically through OpenShift S2I or source to image. So it basically builds your image, deploy it, and it basically enables continuous integration. So as you can see, everything else is being taken care of by OpenShift. You, as a developer, you just commit and push to your Git. Everything else is taken care of by OpenShift. And that's actually the beauty of that. Otherwise, with Kubernetes, you have to do a lot of operations to get that up and running. In my talks, I usually talk about the productivity features of OpenShift for developers, and I want to actually highlight some of those. The first one. So as you saw me, in those commands that I showed you earlier, they were all CLI commands from the command line interface. You've got to put all those commands. You have to remember. With OpenShift, you get that too, but obviously you can do everything from a single graphical user interface, and you can actually work from developer or operations perspective, administrator perspective. So whatever you want to do with OpenShift, you can just do it from a simple browser, basically. And you can easily get your image, like, for instance, the first one, you can just point your OpenShift cluster to your Git, and the rest of the process is going to be taken care of by OpenShift. That's all you need to do. It creates an address for you, gives you a URL to your application, and every time you need to scale it, you just basically press a button, it creates a new pod, or if you leave it to do it for you automatically, it will basically take care of that. Or if you want to kind of, upload your container image, you can just do it there. So it's super simple. You don't need to learn any commands. Everything is going to be taken care of by OpenShift. The second and the most important aspect, Kubernetes offerings differ from one platform to another. So almost every major cloud provider offers a different flavor of Kubernetes. You get different sets of add-ons, instructions for connecting your applications to your cloud resources, plugins. So, in most cases, all those instructions are specific to that specific public cloud platform. Whereas with OpenShift Container Platform, your experience and the way you interact with the platform, let's say through the OpenShift Web Console, stays the same. So the one that I mentioned here, that's Web Console. That's OpenShift Web Console. So everything is exactly the same. Whether you've got your OpenShift on AWS, Azure, IBM Cloud, Google Cloud, it's exactly the same experience. And that's one of the features that many companies are actually using OpenShift these days, because they don't want to train different teams on different public cloud environments. They want to have one team to work on OpenShift and then deploy that application everywhere. So that's one of the important aspects of OpenShift, if you want to have a single team, a single deployment, and then being able to apply it everywhere. And then finally, I'm basically trying to sum it up, but there's so many advantages. But Kubernetes is an open source project, whereas OpenShift is a product based on an open source project. So what you get with OpenShift is, comparing Kubernetes to OpenShift is like that classical example of comparing an engine with a car. So obviously with a car, you can't get, with an engine, you can't do much. You can't go from point A to B. And you need to assemble it with other components in order to become productive. OpenShift is like a car. It's right there for you to kind of sit in and start driving. And that's basically what OpenShift offers to developers. But the most important one is you get security releases and security updates and regular releases basically at every level of the container stack and throughout the application lifecycle. So you get enterprise support, you get certification for your platform and app containers. Everything is going to be there, and obviously compliance and so many other things. And again, that's why a lot of enterprise companies are basically using OpenShift rather than using Kubernetes. One more important point is about multi-tenancy. OpenShift offers you this sort of independent instances of one or multiple applications in a shared environment. So you could have your development team, testing team, a staging team, and production team all kind of working in the same shared environment, but they're all working in silos. And you've got full access to kind of, assign different sort of privileges in terms of workload, security, network policies, and resource quotas. So each team has their own sort of privileges, and you can easily put them on the same platform. This is one of the most important aspects of OpenShift for enterprise applications, multi-tenancy. So partitioning your non-production environment from your production environment. And then the beauty of that is, if you've got your development team in one space, in one project, once that code is ready and it passes all the tests, let's say in project B, then you can easily push it to production without, kind of trying to move it from one platform to another. Everything happens in the same shared environment. And then there's another important aspect, which is operators. Operators are small programs in your cluster that monitors your applications continuously. And also operators are ways for you to package your solution as an ISV or a software vendor to basically make it available to all OpenShift clusters around the world. So this way you can package your solution, and then it becomes, and the operator hub is like the app store on your phone, for instance. So anyone who's looking for your solution, they can easily look it up in the operator hub within their OpenShift cluster, and they can easily install that with one click. And that basically becomes available to their entire cluster, and they can decide what projects can actually use them. So again, another important factor that you can't find them in the competitive offerings. And I'm going to give you a quick example on what sort of operators are quite important for developers and operation engineers. So first, let's talk about code-ready workspaces. So, developers often spend too much time configuring their development environment, adding new libraries, dependencies, and so forth. And it becomes even a bigger problem when you're dealing with a big project. So when developers are collaborating on a big project, it's always like, they have to make certain changes to their environment and let their colleagues know, or kind of share their environment via different storage techniques, or just sometimes email them. Seriously, I've seen that. So when others want to try it, it becomes that big problem. It works on my machine, and they say, hey, it doesn't work on mine, but you say, hey, it works on my machine. And that's actually a big problem. So with code-ready workspaces, you can actually overcome some of those issues. So code-ready workspaces is a cloud-native application environment that allows you to share an instance of your workspace, including all the libraries, dependencies, and tools. Easily. All you need to do is add your libraries and dependencies, create a workspace, and start coding. Whatever you're doing right here, you can easily just share that environment with someone in India, and they can easily just access that through a simple URL, and then they can start coding from a simple browser. They don't even need to have an IDE installed. They can easily start working from an IDE, from a simple browser. But if they've got an IDE like VS Code, it's just a plugin, and they can just point that plugin to the workspace, and they can start coding. And they can even start coding in production. So there are so many advantages to code-ready workspaces. And how you can actually install code-ready workspaces is basically the same thing that I just explained to you. Is an operator within OpenShift cluster. So you look it up and just install that, and it becomes available to all your users in your cluster, and they can easily start working from a simple browser. But you can even just share that browser with them. You don't even need to ask them to go and access the cluster. But this is just for you to install to start a new workspace and then share it with everyone. And this is how you install it, basically just one click, and that becomes available. The next one is Tekton. So what if you were to build, test, deploy apps to Kubernetes using an open source, vendor-neutral, Kubernetes native framework? So that's the promise of Tekton, a set of shared components for building CI/CD, continuous integration and continuous delivery systems. And it's managed by open source CDF, Continuous Delivery Foundation. So the goal is to modernize continuous delivery by providing industry specification for pipelines, workflows, and other building blocks. So Tekton is there to let you, build, test, deploy across multiple cloud providers or even on-premise systems by abstracting the underlying implementation. How does Tekton work? Tekton Pipeline Project provides Kubernetes-style resources for declaring CI/CD-style pipeline. These resources are naturally described in YAML and stored in a code repository. And you can easily install the entire thing as an operator in your cluster, again, with one click. And the whole thing becomes available to your entire developers and operation engineers. And those custom resource extensions can easily be provided to Kubernetes to define pipelines and related concepts within OpenShift. And just for you to know that CDF, Continuous Delivery Foundation, serves as the vendor-neutral home of many, fastest growing projects for CI/CD, including Jenkins, Nginx, and Tekton. And CDF obviously supports DevOps practitioners, with an open model and training industry guidelines. And obviously, IBM is a premier sponsor of CDF, and we are actively participating in this community and its ecosystem to help shape the future. So that's what basically I just wanted to give you a quick intro about what IBM is doing in the CD Foundation as CDF as well. And as I said, Tekton is an operator. You can easily look it up and then install it as an operator. And here's the last part that I wanted to tell you. So if you want to build and deploy all your applications from a single control plane, that's a promise of IBM Cloud Satellite. So IBM Cloud Satellite basically allows you to access all your cloud resources, whether it's on-premise, on edge devices, or your OpenShift on different cloud environments. You can easily access them all from a single, simple control plane. And that's basically the promise of IBM Cloud Satellite. You just have to point your clusters, point your resources, pool of resources to your IBM Cloud Satellite, and everything else can be easily defined and deployed. And you can deploy and build your applications and deploy it to each and every one of them. There's a very good video on YouTube. If you look up IBM Cloud Satellite, you can even turn your, let's say, Intel NUC, small computers into a resource for your IBM Cloud Satellite, and then you can easily just install your applications and deploy them into those machines, and turn literally any device running Linux around the world into your resources, and then deploy from anywhere using IBM Cloud Satellite. So that's the promise of IBM Cloud Satellite. It's absolutely amazing. You can easily just turn any computers into your cloud resource. And obviously that gives you the ability to point your OpenShift clusters on any cloud to that simple single control plane. Let me give you one example. So there is this client in Los Angeles, a construction company, and they wanted to make sure that construction workers who are entering the site, they're basically wearing, hard hat or hard helmet, basically, when they're entering the site. And they were using a number of cameras on site. So the way it was, if we wanted to work like this, it should have been all those cameras had to be connected to cloud. So there had to be like a delay for the processing of the images coming in. And then obviously, by the time those images were going back to the site to kind of signal who's not complying with the rules, it could have been very late and somebody could have been injured. Whereas this way, with IBM Cloud Satellite, you can easily turn any machine on site into a IBM Cloud service, and you can easily run that service for image analysis, for computer vision on that machine, and the rest you can easily just deploy those services from your IBM Cloud Satellite. So this way, you bring your edge, your public cloud services to your edge, basically to your edge device in a simple way. And again, it takes about 5 minutes if you look at that video. If you search for IBM Cloud Satellite, then make sure you look for this particular one. It exactly shows you how you can do that. Just put it on a USB device and then put it in your machine, and that's it. Your services can be easily deployed on that machine. So that's just one example of what you can do to bring public cloud services, IBM Cloud Services, or OpenShift on your edge devices, on your machines on site. Last, since I've got a little bit of time left, I want to tell you about our OpenShift World Tour. So if you search for OpenShift World Tour or Build a Smart on Kubernetes, this is our initiative that we've been running a lot of since the topic of my talk is about cloud native, we've got a great, sort of educational series on cloud native development, building applications with OpenShift and running different applications in Kubernetes and OpenShift. And I'm going to give you the examples here. So here, my series of videos is about 8 hours. So in this series, I basically show you how you can containerize your applications with Docker, how you can deploy and manage your applications with Kubernetes, and then I'll take you to OpenShift and I'll show you how you can do it with OpenShift Web Console in a simple one-click notion, as I said, and also show you how you can continue working from the CLI inside OpenShift. That's about 2 hours and a half, basically, of video. And then I'll show you code-ready workspaces. So if you go on OpenShift Portal, you can find all these videos. It's a series taking you from the simple examples of what microservices are, how you can actually create cloud-native applications, all the way to code-ready workspaces and also code-ready containers, which is the local version of OpenShift on your machine. So this educational series is free of charge. Feel free to go on that developer.ibm.com and find them. It's a great resource. With that, I just want to thank you for being here and listening to my talk. Thank you. Any questions? Yes, please.
Yeah, thanks for the very good talk.
Welcome.
So I have a question regarding DNS. So what makes the applications deployed onto the, say, OpenShift available from the internet? Is there anything like a controller or ingress that allows public?
Yes. So there's this concept called satellite link that basically all the specifications are on the website. You can easily look it up, and it basically points it basically creates this sort of VM kind of on your machine that basically points to the IBM Cloud Satellite and then makes it available as a pool of resources to your Cloud Satellite, so you can easily just deploy applications to that. And it works very well, by the way. I've tried that with different machines, with small Intel nukes, and even like we are talking about Raspberry Pis at some point. But again, we haven't done it. You can actually put OpenShift on Raspberry Pis, but like we haven't done it for this one. But yeah, it's quite simple. You're welcome. Any other questions? Cool. Great. Thank you so much.